All right, welcome to this tutorial on how to name and formula write for a covalent compound. So the first thing we'll do is we'll learn how to write a name from a formula, and then we'll learn how to write a formula from a name, and then I'm going to give you a little summary table of both ionic and covalent naming just so that you can keep them straight. All right, so we're going to learn how to go from a formula to a name for a covalent compound. So remember, covalent compounds contain only nonmetals, right? So we've got nonmetals bonded to nonmetals only. So we're going to name them differently than we did ionic compounds. And you're going to need these things right here. These are called Greek prefixes. And your Greek prefixes are little prefixes that you can put on the front of your nonmetal names to indicate the number of atoms present in the compound. So let's do an example. So here we have water, right? So we know that the common name is water, but we want to give it a chemical name. So to do that, we're going to just go ahead and give prefixes to the names of the elements. So this is hydrogen, and there are two of them. So we know that we can just look at the prefix for 2 is di, and we'll write dihydrogen. And then, of course, there's an oxygen, and there's one of them. So the prefix for 1 is mono, so the rest of it becomes monoxide. So dihydrogen, 2 hydrogens, monoxide, 1 oxygen. So let's write some rules. All right, so the first rule to naming a covalent compound is you're going to name the first nonmetal, just like we did here, hydrogen, and we'll add a prefix to indicate how many there are in the compound. In this case, there were 2, so we added the prefix di. Now, the second rule is that you'll name the second nonmetal, and most covalent compounds contain only, well, not most, but most of them that you'll see will only contain 2 nonmetals. So the second one will be the last nonmetal in the compound. So you named the nonmetal, so oxygen, and then we added a prefix, mono, to indicate how many, and then we changed the ending to "ide." So there are a few things you need to know because there are some little subtle nuances. So the first little thing you need to know is that if the first element, there's only one of them, then you don't use a prefix. So let me do another example. So in this compound, we have a carbon and there's only one of them. So you wouldn't say monocarbon, you would just call that carbon because it's the first element and it only has one of them. And then of course you would go ahead and name the oxygen, but you would make it oxide. So you're going to add that "ide" ending, and then there are 2 of them. So you'll use the prefix di, so it becomes carbon dioxide. And another thing that you need to know is that if when you're putting the prefix on your nonmetal and it ends up putting an A or an O on the prefix next to an A or an O on the name of the nonmetal, that you would drop the vowel off the prefix. So for example, if you had 1 oxygen in your compound, you wouldn't say monoxide, you would drop that O and make it monoxide. Or like for example, if you had 9 oxygens, you wouldn't say nona-oxide, you would just say non-oxide. But you don't ever do that for I's. So whenever you have like 3 iodines, you don't drop the I, it's just triiodide. So let's do an example of that. So here we have 1 oxygen, but remember, it's the first element in the compound, and if there's only one, you don't say monoxygen, you would just say oxygen. And then you've got, in this case, 2 iodides, so you don't drop the I, you would just say diiodide. So it becomes oxygen diiodide. Okay, so let's go name to formula for a covalent compound. So here I've given you the name of the compound, diphosphorus trinitride, and so now it just becomes a matter of working backwards. So if you remember, di means 2, and phosphorus is just phosphoruses, so P2, and then trinitride means 3 nitrogens, so N3. So it's P2N3 is your compound. Let's do another one. Okay, so we know this is a covalent compound because sulfur and chloride or chlorine are both nonmetals, but also you see prefixes. So whenever you see prefixes, you know you're dealing with a covalent compound. So sulfur is S, and there's no prefix, so that means there's just one of them. And then hexa means 6, and chloride means chlorine, so there's 6 chlorines. So sulfur hexachloride is SCl6. Okay, and lastly, we're going to summarize how to name both ionic and covalent compounds. So I made a little table. You'll probably want to write this down. So we've got, does your compound start with a metal or these 2 polyatomic ions? If you say yes, then we're talking an ionic compound. Ionic compounds contain polyatomic, or they don't contain polyatomic ions. If they contain polyatomic ions, you must memorize your polyatomic ions. If your polyatomic ion's an anion, then you just name your cation and you add the name of your polyatomic anion. So LiNO3 becomes lithium, sorry, that should say nitrate. Okay, there, I fixed it. So lithium nitrate. And then if your polyatomic ion is your cation, like ammonium, and then you just say ammonium, and then of course your anion, which is monatomic, becomes chloride. If your ionic compound is just a metal and a nonmetal, like no polyatomic ions, if your metal is not transition, you name the cation and then you name the anion with an ide ending, like sodium chloride. If your metal is transition, you need to use Roman numerals to indicate the charge on the transition metal. So FeO, iron is transition, so that's iron 2 oxide. 2 indicates the charge on your iron. If your compound does not start with a metal or ammonium and hydronium, that means you've got a covalent compound, or a molecular compound is another way they call it in textbooks. So you've got a nonmetal bonded to a nonmetal, which means you need to use Greek prefixes and then give the last element an ide ending. So N2O becomes dinitrogen monoxide. And that lovingly brings us to the end of our presentation on how to name and write formulas for covalent compounds.